Hey everyone, welcome back to the NumPy series. In the last video, we saw how to slice and dice a NumPy array. So just like you can slice and dice your list, you can slice and dice your NumPy array as well, and that we have checked out in the last video. But what if, let's say, from this array that I have in front of me, I want to get or fetch the items based on some condition. So let's say my condition is that I want to get all the items in this array which are greater than 25. So this is my condition. Now this returns the array in the output, a one-dimensional array with the Boolean value false and true. Wherever the condition is true, it returns true. And wherever, for whichever element the condition is false, it is returning the Boolean value false. Now let's save it down in a variable, condition. And if I go ahead and print condition, I have my one-dimensional array with Boolean values true and false. Now, let's say from this array, I want to only filter the values where the values are greater than 25. So, in the NumPy array, we can say array, square brackets, and then give the condition. So here the condition we have saved in the condition variable. And what it does, it returns the values where the condition is true. So pretty nifty, right? Now, what if we have a 2D array? Can we apply this condition to 2D array as well? Let's check. So again, let's just directly put the condition here, greater than 25. And it is giving me index error because this should be 2D array. It's returning 30. Only one value I have is greater than 25. So let's just go ahead and change this to 15 maybe. So now it is returning 20, 25, 30. What if I make this value 100? It returns 100, 20, 25, 30. So in all the cases, guys, it's returning a 1D array, a one-dimensional array. So how does it work? It is flattening the matching elements in a 1D output. So irrespective of whether you have three-dimensional array or five-dimensional array, doesn't matter. In the output, you'll always get a 1D array whenever you apply condition like this. So it will flatten the output to 1D array. So now let's move to fancy indexing. So fancy indexing means selecting specific elements by their position, not based on condition, but based on their position. So again, let's take our array. And this is a one-dimensional array, 1D array. And let's say I want to select items at specific positions. So not based on condition, but based on their position. So let's say I want to select elements at index 1, 3, and 4. So how can we do that? We can give square brackets, and inside the square brackets, I have to give the list or array of indices that I want to select. So let's say we want the item or the element at index 1, 3, and 4. So this is what we are getting, 20, 40, and 50. So this is not possible in the case of list. You cannot do such sort of indexing, but for NumPy array, this is available to us. We can also do this fancy indexing for 2D arrays. So let's grab a 2D array. Now let's say I want to select a specific row. So I can say array 2D, and the first value that I pass, I can pass a list here. This is for the rows, the first dimension. So this is for the first dimension. So I can say I want the array at index 1. So it will give me the second row here, right? And then let's say I want column also. I want 25 and 30. So here I can pass the index of second dimension. That would be 1 and 2. So it's returning 25 and 30. So what are we doing here? We have our 2D array and we are passing, you can say, the list of rows, comma, list of columns. Or you can also say that you're passing, you have your 2D array, you're passing list of index or indices, first dimension, comma, list of indices for second dimension. If you're working with 3 dimension, then you would pass one more argument, list of indices for third dimension, and so on and so forth for other dimension, higher dimension as well. Let's try one more. If I say array 2D, and here if I give the row indices, so let's say that is 0, 1 or 2, and the column I say is 2 will not work because I don't have the index. And for the column, let's just say 0, 2. Let's run it. So what just happened here? It's returning 5 and 30. Value 5 and 30. Why so? Because the way this works is, it will basically create a pair. So this 0, 0 is one pair. So it will use the two arrays together and create a pair. So 0, 0 is one pair. What is the item at 0, 0? This is the item, 0th row and 0th column. So this is the item. And then 1, 2. 1, 2 is 1 is this second row and 2 is the third column. 2 is the index of the third column. So 1, 2 is 30. So it's returning 30 in the output. So it is pairing each row and column index from the list you gave here and then picking the elements accordingly. Now, if you make this, maybe you add something more here, 1. Will this work? Let's try. No, it is giving us index error. It is saying shape mismatch. So the rows and the column arrays must be of the same length. Now you might say, but here they are not of the same length, which is okay because here what is happening? We're just selecting the first row and then saying, go ahead and select the first, the second and third item of the first row. But here, the NumPy would not know how to resolve this, how to kind of create the pairs. So this cannot be broadcasted, which the broadcasting term, again, we'll discuss it in the future videos. But the rule here is that the rows and arrays must be of the same length. And then it forms the pairs and each pair returns one selected item. And that's a quick introduction to Boolean and fancy indexing. These features make data selection very easy, very powerful, and very fast, especially when you're working with large data sets. In the next video, we'll explore even more features of NumPy, so stay tuned. If you're enjoying the series, don't forget to like, subscribe, and hit the bell icon. Thank you for watching.